All right, guys, so today we're going to be starting Chapter 9, which has to do with conic sections. If you are currently watching this video, then I would encourage you to go to YouTube and Google conic section animation so that you can kind of have a visual of what it is that we're talking about. I'm just going to go ahead and jump straight into what they are. There are 4 types of conics. Today we're going to focus on parabolas and circles. Cool? The first thing that I would like to start with is giving you the general equation of what a conic is. Cool? So the general equation of conics has this form: ax squared plus bxy plus cy squared plus dx plus ey plus f is equal to 0. Cool? Where a, b, c, d, e, and f are elements of the real numbers. So in other words, it can be a fraction, it can be an integer, it can be a decimal. It just has to be a real number. Cool? No imaginary numbers here. So a, b, c, d, e, f are elements of the real numbers. Cool? Well, this is the equation for all of them. So we're going to have to learn how to differentiate one versus the other. Okay, and it all comes down to what those numbers are and certain things, like whether it's positive, whether it's negative, and whatnot. As we learn each one of these conics, then I will tell you how to differentiate them. Okay. The other thing I want to mention: the order in which you write this does not really matter. Cool. So it doesn't matter if you put ay squared first and then bx squared. All it matters is, in order to be in the general form, really, is that everything is on one side and it's equal to 0. That's all that it matters to be in general form. Cool? Now, some of the observations you need to make about this is that you are dealing with 2 variables. Cool? We have x and y. The other observation I would like you to make is that you could potentially have 2 of them that are squared. Or you could potentially, maybe that's 0, you could potentially just have one of them that's squared. Cool? We can't have them both be zeros, both of those, because then at that point we're not really dealing with a conic anymore. We might be dealing with some type of line. Cool? So we can at least have one of them square. We could have both of them square. And as we learn all of these conics, then I'll start telling you how you can differentiate. Cool? So the first conic we'll start out with today is called a circle. Cool. Does anyone know what a circle is? Give me a definition. Come on. Participate on this video. Anyone? What do you think a circle is? A what? A line rotated.
Like at the same distance from the center.
Okay, I like where you're going with this. A line rotated that's the same distance from what? From a center point. Cool. I like that. Maybe the word line can throw someone off, but I like what you're saying. Anyone want to add anything to that? Okay, points. Interesting. So a bunch of points that are the same distance from a center point. Do you guys agree? Can I put that in a more formal definition? Is that okay? Cool. No sides? No sides. Okay. So, how about we say the set of all points? So instead of lines, I want to use points, and I want to use all of them because there is an infinite amount of points that we can put on a circle. We're going to put this on the plane to make this easier. So let's call those points x, comma, y. Cool? The set of all points that are, you said same distance, right? So that are equidistant. Cool. So the set of all points x, y that are equidistant from where? From a point, and that point we're going to call the center. Cool? From a point called the center. Now, for the sake of a proof that we're going to do here very soon, let's call that center, instead of xy, because I don't want to get confused, let's call it hk. I'm picking hk arbitrarily because that's what the formula kind of uses. So I just want to make sure that everything correlates. Cool? But does this definition make sense to what you know a circle is? Yes? All right. So we're going to come up with a formula for this. Okay? Now, the formula of a circle can take the form of this. But it's kind of hard to start teaching you with circles with this, because this could be anything. So let me show you how a formula for a circle would look like. Cool? Alright, first of all, let's do a little sketch so we can do a proof. So let's say that that's HK. And we got ourselves a beautiful circle right here. Look at that. Cool. So we got HK, that's our center. And I'm just going to randomly pick a point. So let's say that this point right here is XY. Agreed? But we have an infinite amount of points. You can pick any point you like. Well, I'm going to use the definition. According to the definition, in order for you to have a circle, I need to know what? Just the distance. Because this distance right here should be the same distance as if I go here. And that's what creates a circle. So the question to me, from me to you, is if you go back to geometry, that line that I drew has a name. It's called the radius. How could I find that radius? How long that radius is? The distance formula. I'm going to find the distance between this point and this point. So going back to algebra 1-ish, the distance formula says distance is equal to the square root of what? y2 minus y1 squared plus x2 minus x1 squared. The order typically, when we see this in textbooks, they're the other way, but remember with addition it doesn't matter, so it ends up giving you the same thing. Cool, but this is the distance formula, okay? So let's say I want to find the distance between x, y, and hk. So we're going to say the square root of, okay? Can I use the x first? Are you guys okay with that? This part first? Okay. What if I do that minus that? I would get x minus h, right? And we have to square it. Agreed? Plus y minus k square. And that gives you the distance for the radius, right? Well, that's the formula for a circle, but we're just going to do one step just to kind of clean it up. A lot of people don't like to see square roots, so let's just get rid of it. How can I get rid of that square root? Square both sides. So if I square both sides, what happens? I get r squared is equal to what? X minus h squared plus y minus k squared. This right here is known as the standard form of a circle. Cool? So that is a formula that you will have to memorize for the test. I will not be providing that for you. Okay? The reason why we like this form is, let's use this formula in this diagram. There are two things that we really care about a circle in order to be able to successfully sketch this. If we know the if we know the center and we know the radius, we can easily sketch a circle. If you look at this formula, both of those things are very easily found. Because according to my diagram, my center should be located at HK. And HK happens to be in my formula. So in other words, the center, once your formula is in this format, your center will be located at H comma K. Few pointers I want to give you. Notice how in the formula it says it X minus and then Y minus, but the center is at the positive of it. That means you have to think opposite. So if you have a negative here, it should be positive. If you have a positive, it should be negative. Cool? The other thing I like to mention is, a lot of students get confused, like, does the H go with the Y? Does the K go with the Y? Like, they forget that, they get nervous. Don't think so much about HK. What I like to remember is, like, when you're coming up with the center, the X coordinate would come from the X, I guess, parenthesis per se, and then the Y coordinate would come from the Y. Cool? So the center comes from there, and then the other thing that we need for a circle would be the radius. Well, how would you find the radius if you have this form? Take the square root of that. Cool? This is going to be some number, right? So if I gave you 100, that means that the radius is 10, not 100. Cool? You're going to have to take the square root of it. Cool? Now, typically when you take the square root of, you should consider plus or minus, but why would minus not make sense for this problem? Because we're talking about a distance. Cool? Alright, questions about the standard form of a circle? We're good? Alright, so we're ready to practice and sketch the following. Cool? So let's say that I give you, I don't know, x plus 7 squared plus y minus 3 squared equals 25. Cool? And your job is to sketch this. All right. What are some things that you would probably need in order to sketch this? The center. Okay? Could anybody tell me where the center is located? Negative 7, comma 3. Cool? What else would I need? The radius. My radius is going to be what? 5. Okay. Do you think that this is enough information for yourself to sketch a circle? Yes? Okay. Now, for those of you that are wondering, I'm not really sure how I could use this information to sketch. Let's go ahead and kind of give you an example. Cool? So, again, it's just a sketch. It doesn't have to be perfect. So, 2, 3, 4, 5, 6, 7, 8. Okay, so for sure our center is going to be at negative 7, 3. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So about right there. How could you use that in the fact that the radius is 5 to help you sketch it? Yes. Good. And that's exactly what I want you to do. I don't want you to try to come up with a whole bunch of points. Just go 5 up, 5 down, 5 left, 5 right, and plot those points. That is exactly how I'm going to grade things for this class. When I ask you to sketch, I'm going to need to make sure that the center is where you told me, and that there are 4 points that are exactly where they need to be. Cool? So if I go 5 units up, what point should I be at? 8. So 3, 4, 5, 6, 7, 8. So this point right here should be negative 7, 8. If I go 5 to the right, I should be at negative 2, 3. So about right there. So this point should be negative 2, 3. And my circle is going to start taking shape. Cool? If I go 5 units down, where should I be? At negative 7, negative 2, right? So negative 7, negative 2. And again, you can already tell I did not draw this to scale. This is definitely not looking like a circle, but it's okay. So, and that's the same thing for you. I'm not going to be very picky that it doesn't look like a circle, but I need to make sure that that's at negative 2, 3, and that this is at negative 7, negative 2, right? And your last point would be where? Negative 12, comma 3. So, I don't know, maybe there. And that is a horribly drawn circle, but that's what I will be looking for. Cool? Yes? You will always have a way to find the center before sketching. Cool? What I could ask you maybe is I could give you like the sketch and ask you to come up with a formula. Cool? But I think, first of all, if I were to give you that, I will give you an actual coordinate plane where it's very easy to view where the center is and where everything's at. Cool? But other than that, if I'm going to give you the equation, then there's a way for you to find the center. Cool? All right. Questions about how to sketch a circle? We're good? All right. Well, what if I give you same question, but then I give you something like this? X squared minus 6x plus y squared minus 2y plus 6 equal to 0. First of all, how do you even know that's a circle? Okay. Well, I haven't said anything. I didn't even say this was a circle, right? All I said was sketch, right? So, but let's look at this. You're deducing we're talking about circles, so this got to be a circle, right? So let's find out why this is a circle. Because what I just gave you is, if you remember, when we started this, I just gave you the general equation. Now, it is a circle, but let's talk about why it is a circle, okay? If you analyze the formula that we came up with for the standard form, and if you analyze the example that I gave you previously, couldn't you technically just square this, so find out what this is, distribute everything out, and then set it equal to 0. And eventually would look maybe something like this. Yes? Well, think about it. If you distribute everything out here, would you have an x squared and a y squared? You would. Which means that in order for you to have a circle, you're going to need to have an x squared and a y squared. Which you do. Cool? Secondly, do you notice that if I were to expand this out, this would be a positive x squared, and so would this. This would also be a positive y squared. Always. In order to have a circle, not only do you need an x squared and a y squared, but they both have to be positive. Cool? And there's one last requirement. It didn't happen on this problem, but if I were to multiply all of this out, do you guys notice that this would be 1x squared and this would be 1y squared? They have to have the same number up front. Like, for example, if I had a 2 there and a 2 there, then that would have been a 4x squared and a 4y squared. But it's the exact same number. In order to be a circle, the three requirements are, you need an x squared and a y squared. They both need to be positive, and they both have to have the same coefficients. Cool? So the three requirements for a circle. We have an x squared and a y squared. They're both positive, and the coefficients are the same. And that's how we know that this is a circle. Cool? Well, now that we know this circle, awesome. If I could just figure out where the center is and where the radius is, then I could just sketch it. But this form is not very friendly for us. And that's why the standard form is awesome, because the standard form, you can just look at it and be like, oh, the center is that, the radius is this. The general form sucks in that respect. So we are going to then make this look like the standard form so that we can sketch it. The question is, how can I make this, how can I take something like this and make it look like maybe something like that? Yes, sir.
You could factor out the x and y, and then you will have like x squared.
I can't, you have kind of the right idea. There's going to be some factoring in here that we're going to do, but I can't just factor the way it is because not every term has an x and not every term has a y. So I'm going to move some stuff around. I'm going to use something called completing the square from Algebra 2. It's been a while, so I'll help you refresh as we go along. But my assumption is that if you're watching this video or you're sitting in this class, that you've seen it before, so I'm not going to go in super detail. I'm just going to refresh your memory. Cool? I'm going to have to complete the square, and I'm going to have to complete the square twice because I have two variables, x and y, and both of those are square. So in order to complete the square, you must remember that you need to take your constants and move it to the other side first. So in order to do that, I'm going to have to subtract it. So I'm going to be left with x squared minus 6x plus y squared minus 2y equals negative 6. Okay? Now, I do want to use this idea of factoring, but I have to complete the square. What that means is that you're going to introduce a number in here that was not there, that you're going to bring in to help you complete the square. So we're looking for this unknown number. So what we're going to do, what I typically tell my students to do, is to add this unknown space, because you're going to put a number in there that you're going to find here in just a second. And also with this one, because you got to do it with the y square. However, if you're going to add a number to the left side, you have to add a number to the right side. Okay? So now the question, does anyone remember from Algebra 2 how to find that number? Yes, sir. Close. It's taking this value, the one with the first power, dividing it by 2, and then squaring it. Cool? Yes, so I'm going to use the letters how you learn it. So it's like taking b divided by 2 and then squaring it. Okay? So in this case, if you take negative 6 and divide it by 2, you get negative 3. And if you square that, you get a 9. So that means you put a 9 there, and you also put a 9 there. Cool? If you do the same thing here, you're going to get what? A 1. If you put a 1 there, then you put a 1 there. Cool? Now, the whole purpose of this is now we can group this, and we can factor. Okay? If you do x squared minus 6x plus 9, what does that factor to be? X minus 3 squared. This is called completing the square because it became a perfect square. X minus 3 times x minus 3. Cool? Plus, what about that one? Y minus 1 squared is equal to what? 4. And I like where we're at. I love where we're at. We're in the standard form. We just completed the square. Now in the standard form, you can tell me what is the vertex and what is the radius. What's the vertex? The vertex is 3, 1. I'm sorry, the center. I got ahead of myself. The center for this circle, thank you, is 3, 1. And what is the radius? The radius is 2. Could you sketch this for me? Cool. So go ahead and take your time and go ahead and sketch this out. I'm going to go ahead and pause the video and check your answer when you are done. Alright, I'm assuming you already gave it a go. Here's your answer. Check your work. Are there any questions about circles before we move on to parabolas? Overall, I think, we could do more examples, but I think circles are pretty straightforward, okay? And you'll get plenty of practice on the homework, okay? Alright, so let's talk about parabolas. You've learned about parabolas in an algebraic way, cool? If you go back to Algebra 2, there was a few things that you should know about a parabola, okay? For example, you know that a parabola has a vertex, which could be either your lowest value or your highest value, right? But what other parts would you tell me that you know about a parabola, other than the vertex, that you would say, like, this is called blah, 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 blah? Is there anything else that you know, or any other parts of the parabola that you know of? Yes. Go ahead. There's a focus point. And a lot of you guys should be looking at her like, how do you know that? Because they never even talked about that in algebra. And I agree, most algebra teachers probably did not talk to you about something called the focus. That's because it's out of the scope of their class. Because they were focusing on parabolas as a function. And we're going to focus on parabolas as a conic section. Okay? And the focus is a very important point that we're going to use. There's another part called the directrix, which, again, if you took algebra, like, I have no idea, all of this is foreign to me, okay? So, I'm going to give you a definition, because most people that I ask, like, can you give me a definition of what a parabola is? With what you currently know, what would you say? For those of you in the video, everyone's doing a hand gesture, right? And it's typically going up or going down. And that's my definition that I typically get every year. What's a parabola? That. Which is like, okay, cool, what does that mean, right? So here's the definition. I don't feel like rewriting all this, but I'll go ahead and project it. So if you're watching the video, go ahead and copy it down and then pause the video. Here we go. Let me zoom in. Let me zoom in. Hold on. This is why I don't want to write it all, because it's a long definition, okay? So if you're watching the video, go ahead and pause it, copy it down, and when you're ready to go, hit play. Alright, so I'm assuming you've written down the definition, and it's totally something new you haven't really seen about parabolas, so let's talk about what it all means, cool? So in the definition, you mentioned two things, something called a focus and something called a directrix. And basically, it all depends on that. If you go back and read the definition, it really depends on that, right? So let's say, for example, that you have some point, and I'm just going to randomly draw, so that point right there, and let's call that point the focus, cool? And then I need to draw a line. According to the definition, there's a line called a directrix. So I'm going to draw a line down here. So that's called the directrix. Cool. Okay, go back and read the definition. So it says, in order to have a parabola, there is all of these points that are equidistant between the focus and the directrix, but it's kind of hard to show you that. So I added a little something to the definition. It said that right in the middle, do you know what a midpoint is? Right in the middle of the focus, and right in the between the focus and the directrix, there's another point called the vertex, which all of you guys are familiar with. Cool? I'm just guesstimating here, so there you go. There's a vertex. Cool? Now, we all know what a parabola looks like since you took Algebra 2. So, again, I'm not drawing this to scale, so let's just pretend this parabola looks something like, I don't know, that. Okay? That's a terrible parabola. But anyways, here's what I want to mention. Notice how the two most important parts of the parabola, because according to the definition, are the focus and the directrix. They're not even on the parabola. You use two things that are not even part of the parabola to create a parabola. Cool? But let's look at the definition. It says the set of all points in a plane that are equidistant from a fixed point. Here's what it means. The distance from here to there is the same as the distance from here to there. Cool? Now, we're going to come up with a formula for this, and in order for you to understand the formula, I'm going to call this distance from here to here, I'm going to call it P. Which means that from here to here is also P. Cool? But that needs to be true anywhere on this parabola. So let's say, for example, that I chose this point right here. Let's call that point x comma y. What that means is that the distance between the focus and that point, so let's call that D1, and the point in the directrix, let's call that D2, they have to be what? Equidistant means the same. That means that D1 should be equal to D2. I obviously did not draw this to scale. It obviously looks that D2 is longer than D1. But with the definition, it should be equal to each other. Now, when we come back from lunch, because I'm not going to be able to finish this before we go to lunch, we are going to use this right here to come up with a formula that will work for any parabola. Cool? So a few things I want to add to the diagram before we leave. Okay? We got a point xy. We're going to call this vertex, for the purposes of our formula, we're going to call that hk. Cool? So we have another point. Cool? Now, if you know that the vertex is hk, and you know that the distance between the vertex and the focus is p, can anybody help me come up with what that point is for the focus? I need a coordinate for it. Yes. H, I agree, not 2k. Think about it. K plus P. Think about it, because the x value should not change, right? It's just P units up. So I need to add P. Cool? Now, I also need to come up with a point here on the directrix. Once again, do you guys agree that technically I'm still going to have H, right? But what's going to be this point if I go down? K minus P. We're going to use all these points to come up with a formula for a parabola when we come back from lunch. Cool? Alright guys, so where we left off is we were trying to prove that according to the definition, the distance between the focus and that point, and the distance between that point and this point, which I realized earlier I kind of messed up. We need this point, not this point, right? You're with me? Because D2, we need this point, and we found that point. That makes no sense. Sorry. But I was trying to rush before lunch. We actually need to find this point. So we need to find the distance between that point and that point, that point and that point. Cool? So before I start using the distance formula, what is this point? So we really don't need this point over here. I apologize, right? We need this point right here, which should be what according to the diagram? X comma K minus P. Very good. Cool? Alright, so first of all, let's see. How would you find the distance for D1? Well, we just talked about the distance formula earlier. So we're going to say we are using this point and this point. I know that everything's kind of all over the place, but just follow the arrow. So we'll find the distance between this point and that point. So can I say x minus h, right? X minus h squared plus y minus k plus p. Y minus k plus p squared. So that's distance 1. Agreed? Okay. What about distance 2? Well, D2, if I'm going to use this point and this point, I'm going to say x minus x squared plus y minus k minus p squared. Yes. No problem. Cool? Alright. I have these two expressions, but according to what I'm trying to prove, and we already know according to the definition, is that D1 and D2 are the same. So I need to set them equal to each other. Before I do so, can I simplify D2? Because that's, we can do a lot to D2. Like, this is 0. And then, I'm sorry? It's the same value because it's x minus x, right? Cool. And then right here, think about it. What I'm left with this. I'm left with that, so can I even go further than that? What would I be left with? Okay. I'll be left with that, right? You guys with me? Without distributing the negative, that's what I will be left with. Yes? So what I'm going to do is I'm going to set d1 equal to d2, so what that means is that I have this. d1, which is x minus h squared plus y minus k plus p squared. That's got to be equal to d2, which came down to be y minus k minus p. Cool? That is technically what a parabola is, but looking at that is not fun. It's not really easy for me to tell what's what. So what we're going to do is we're just going to do a bunch of algebra to it, clean things up, a lot of things will go away, and that's going to lead us to the standard form of a parabola. Cool? The first thing I need you to do is to take this square root away from here. So how can I do that? We're going to square both sides. So if I square that and I square that. Cool? So I need you to actually square it. So what that means is if I do the square here, I'm going to be left with x minus h squared plus y minus k plus p squared equals, what happens if I square that? Well, I know a lot of you guys want to take a lot of extra steps, so for the time's sake, I'm going to skip a few steps. Just trust me in the algebra. But if we square this, it wouldn't be y times y, which would be y squared, right? And then it would be y times this term. But that's going to happen twice, right? So it's going to be minus 2y times k minus p. Cool? And then this term times itself, so negative times negative creates a positive. And then k minus p times k minus p is just k minus p squared. Cool? And I'll take care of that in our next step. Yes? Okay. Now, I actually want to square this as well. Cool? I'm going to leave this one alone, but I want to go ahead and square this as well. Okay? It's very close to the same thing, except that this one has a plus, but it's going to be very similar. You with me? So we're going to leave this alone, x minus h squared plus, this becomes y squared minus 2y times k plus p plus k plus p squared equals, and I'm going to go ahead and continue distributing things on the right. So on the right side now I have y squared minus 2yk plus 2yp plus k squared minus 2kp plus p squared. All of that has just been algebra. Cool? All I did was just distribute everything on the right hand side. Cool? Well, I need to do the same thing on the left. I need to keep distributing here. Okay? One thing real quick, so I'm going to leave this one alone. You'll see why at the end, like why I'm not touching this at all. Okay? So that y squared stays, but this becomes what? 2yk and 2yp, right? Both of those will be negative. So minus 2yk minus 2yp. And then if I multiply this out, that would be a k squared plus 2kp plus p squared equals to all of that mess on the right hand side. Now hopefully, I know this looks horrible, terrible, you recognize that a lot of these things are actually just going to cancel each other out. And that's the reason why we expand it out. Look, if you subtract this y squared from both sides, then it's gone, right? So the trick here is, if you have a term on the left and the right, and they have the exact same sign, they're going to cancel. So the y squared, gone. What else? K squared, gone. Negative 2yk and negative 2yk, gone. The negative 2yp will not go away because that's a positive 2yp. Cool? What about the 2kp? No, because it's the opposite sign. What about the p squared? Yes. So in reality, here's what I'm left with. X minus h squared minus 2yp plus 2kp is equal to 2yp minus 2kp. That's all I'm left with. A lot of things went away. But I like where I'm at because I can actually combine some of those things together. Like they will add up because they're the same, right? Can I move both of this to the right-hand side? And if I do so, I would just be left with x minus h squared on the left. And what would I have on the right-hand side? 4yp, because if I add the 2yp, and I already have two of them, that would be 4yp minus 4kp. Yes? And I like what happened on the right, because I could factor that out. What could you factor out on the right-hand side? A 4 and what else? P. And what would you be left with? Y minus k. This right here is known as the standard form for a parabola. Okay, you don't have to know how to do all of this. You know that in this class I don't like to just give you formulas. This was the proof of where this formula came from. But why in the world do I like this formula? If you go back to your sketch, what do you notice HK represents? The vertex. Do you notice how now in the standard form HK is present? So just by looking at this, you can tell me that the vertex is whatever these numbers are, but the opposite of them, right? Now, the other thing that you can tell me just by looking at this equation, it's what is P, right? But what does P represent as far as your diagram? The distance between what? The vertex and what? The focus and the directrix. So with the standard form, you're going to be able to figure out the vertex and the p-value. And why do you need the p-value? Because with the p-value, you can figure out what the focus is, and you can figure out what the directrix is. Cool? All right. You need to memorize that formula. However, there's another one. We're not going to derive it. I'm just going to go ahead and give it to you. Because a parabola, back in Algebra 2, in order to be talking about functions, a parabola had to either be opening up or down. That would pass the vertical line test. But a conic doesn't have to be a function. We could have parabolas that go left and right. Cool? So this right here would give us what I like to call a vertical parabola. Because they open either up or down. Now, how would you know whether a parabola is opening up or down back in Algebra 2? If it was negative. If the leading coefficient was negative, then you know you were opening down. But this thing is not really written in that way. However, it's still the same thing. If there is a negative in here, typically you will find the negative here. If this term right here, the 4p, is negative, then you're going to be opening downward. Cool? All right. The equation for a horizontal parabola, it's very similar. It looks like this. What do you notice? It's literally, I just switched the position of the two things. Because if I'm going to be opening left or right, then instead of being x squared, I need to be y squared. Cool? But what I still need you to notice is that the vertex is still located at h comma k. Cool? Questions about the formulas itself? Yes. So same thing. What do you think happens if this was negative as far as horizontal? It would go to the left. And this is positive, then it would go to the right. Cool? All right. Ready for practice problem? Let's do this. Okay. Example number 1 for parabolas. Find the standard form for the following. The vertex is located at 0, 0. We'll start out with something simple. And the focus is located at 0, comma, -4. And that's all I'm going to give you. Now, I can give you variations of this problem on the homework. Like I could give you the vertex and the directrix. or I could give you the directrix and the focus. You see what I'm saying? But they'll follow the general same idea. Okay, so we're just going to do one example like this. Any suggestions of how I can go about attacking this problem so that I can find out the equation of this? Yes. We can find P. Cool. Now, for those of you that are visual, which I have a lot of you guys that are that way, sketch this before you even start. Here's 0, 0, and there's my vertex. And here's 0, -4, which is my focus. Now, why would I want to sketch this? Yes. Fantastic. So that you know whether you're going up or down. And how do I know I'm going down? Because the focus should always be on the inside of the parabola. That's how I know I'm going down. Now, the other thing is, now that I know I'm going down, I can go back and make my decision whether I'm using the vertical parabola or the horizontal parabola. So which one am I using? The vertical. So in my mind, here's what I'm thinking. I need to be using x minus h squared equals 4p y minus k. Cool? That's what I need to be using. So, out of this, I know a lot of things just by looking at what I gave you. Now, I think I heard Jose told me, you told me P is 4. How did you know P was 4? Cool. This distance right here is 4. And you already know by the definition that I gave you earlier that that's the P value. So, you know the P value, and what else do you know? You know the vertex. So, you should know the equation. All we're going to do is plug in. So what's the equation for this? If I plug in, this would be x minus what? 0 squared equals 4 times what? 4 times y minus 0. Now I'm going to want you to clean that up. Cool? So what does that clean up to become? X squared equals 16y. Well, we have an issue. Because the way I have this written, this should be going up. And that's where you got to be very careful. You got to throw in your negative because you know it's opening down. Cool? So if you want to avoid making that mistake, I know this makes, I don't like to really say this, but for that P you can throw the negative. But P is a distance, so that's where sometimes I'm like, you just really need to pay attention whether this thing is opening up or down. Cool? So the equation for this would be that. And you will be done. Cool? Yes, sir. No. Matter of fact, that is a great question. See how the question said find the standard form? You are in the standard form. Do not solve for y. Because I know that that's what you're used to. You're going to be like, well, y equals to x squared divided by negative 16. But that's no longer the standard form. The standard form has to look like basically what we gave you here previously. It has to look something similar to that. Cool? So good question. Now, what I could also do, guys, is instead of giving you this, I could have started you with this and asked you for a sketch. So let's say that I didn't give you that. Right away you can tell me that the vertex is 0, 0. Yes? Right away you should be the vertex is 0, 0. But then how do I find my P value? That's where you got to be careful. This right here, if you look at the equation, that number right there represents that right there. It doesn't represent P, it represents 4P. So you would say this is 4P. So how would you find P? You would say 4P equals negative 16, which means that P equals to negative 4 based on the way we have it, right? We know it's a distance. Agreed? Now that you know what P is, and that you know that the vertex, just by looking at it, is 0, 0, could you find the focus? Because you know it goes downward. So, I mean, I already gave you the focus, but according to, with that information, the focus should be at 0, negative 4, right? Now, the one thing I did not give you, which I would like for you to find, is where is the directrix? Well, go to your sketch. The directrix should be where? Should be above. How much? 4. Your directrix should be here. Now, the directrix is a line. So, what is the equation of that line? Y equals 4. So, the directrix for this should be at y equals 4. So there's a variation of the problem, okay? I could have given you, like I said, started you out with you find the equation, or I could give you the equation and ask you to find the things for it. And you can always sketch it. I could always ask you to sketch it, cool? When it comes to sketching wise, I'm not going to be very picky about being perfect, but what I will grade is that this obviously the line is y equals 4, that the vertex is in the correct location, and that the focus is in the correct location, and that you're obviously opening down in this case. I'm not going to check for any more points. Other than that, you're not going to have time to do the quiz. Okay? Questions about this example? I have one more, and that's it. We're good? All right. How could you tell whether remember, because we started the lesson with the general equation of a conic, right? The conic could look like that. So what if I give you a parabola in this form? How could you tell that it's a parabola? So let's go ahead and get that started. So example. Okay. I just gave you and the instructions are going to be to sketch. Cool. I just gave you the general form of a conic. Cool. The question is, how could you tell that this is a parabola? And parabolas are very simple. There's just one term that's square. That's it. If there's only one term square, it's a parabola. Period. Cool. So if you want to write that down, if there's only one term that's square, it's a parabola. Now we want to sketch this. So in order to sketch this, we're going to write this in the standard form. Okay? Which, if you look at this, this is an x squared, so that means that this is going to be a vertical parabola. I need to somehow make this become that. That's our challenge. Now, we've already done this, and we're running out of time, so let's talk about it. We got to complete the square. In order to make this happen, I need to complete the square. Now, here's the thing, though. Compared to the circle I completed the square twice because there were two variables that were being squared. There's only one variable here that's being squared. So everything else that's not being squared needs to go to the other side. So what that means is I'm going to keep the negative 1/2 x squared, and I need to keep the x with it because they go together. But on the other side, I'm going to have what? Y minus 1/2. Okay, I'm not even going to touch that, right? I don't need to complete the square on that. I need to complete the square on this. So what that means is I'm going to have negative 1/2 x squared minus x plus some number that I need to find, which is equal to y minus 1/2 plus a number that I need to find. Now, some of you guys may be thinking, like, get rid of the 1/2, multiply it out so that it's not there. You can do that. So, like, I can multiply by a -2 so that I have a 1 there. Because some people don't like fractions, and that's what I would do. But I chose this example because I want to show you something that most of you guys forgot from Algebra 2. To complete the square, this must be a 1, which is not. And when it's not, you need to take care of it before you complete the square. So that's why I chose this example. So I'm not going to multiply by 2 to make it into a 1. I'm going to show you what you're supposed to do in case it's not that simple. Okay? You need to factor out that 1/2, specifically the negative 1/2. So if I factor out a negative 1/2, what would I be left with inside the parentheses? An x squared for sure. But instead of a minus, now I'm going to have a plus 2x. Very good. Because negative 1/2 times 2 will give you a negative 1. Now you can complete the square with what's on the inside. How or what number goes there? 1. If I have a 1 there, would I also put a 1 there? No. Very good. Because that 1/2 affects it. So I need to multiply it in, which means I need what on this side? A negative 1/2. Cool? All right. So now, real quick, the whole purpose of completing the square here is, what can I do here? It's a perfect square, x plus 1 squared. And if you look at your right-hand side, I have y minus 1. Cool? Now, does this look like the standard form? Close to it. You have to be very careful because, look, the standard form looks like this. You have x minus h, and then you have 4p y minus k. What's the difference between this and what I gave you here? This little number is supposed to be next to this, not to the square term. And that's going to make a difference. Because if you don't, you're going to assume that 4p is 1/2, right? Negative 1/2, which is not. So how would I get rid of that negative 1/2? Divide it out or multiply by negative 2. Yes? If I multiply by negative 2, I get x plus 1 squared equals negative 2 times y minus 1. Now, why did I not multiply it in? Like, why did I do negative 2? Because we need that 4p. We need to know what 4p equals to. If you multiply it in, you're not going to be able to know what 4p is. Okay, the instructions were to sketch this. So I can look at this and I can find out two things. I can find out what the vertex is, which in this case is opposite of this, which would be negative 1, opposite of that, which would be 1. And I can find out what my p-value is. My p-value would be, would it be negative 2? No. You need to figure it out. For p is equal to that, which means that p is equal to negative 1/2. So our p-value is negative 1/2. Okay, now the whole idea was to sketch this, right? So I need a sketch. Now the question is, look at the equation that you have here. Is this going to be up, down, left, or right? Down. It's down because that's negative and because it's an x squared. Cool? So that means my vertex is at negative 1, 1. If it's going down, should my focus be below or above? Below. How much? Half a unit. So right now I'm at 1, right? So that means that 1/2, I should have my focus right there. And what about if I go above? The directrix, specifically at 1.5. Yes? So what that means is the directrix is where? At y equals 1.5. Cool? And the focus is located exactly where? Negative 1, comma 1/2. And this thing again is going to look something maybe like that, because it's opening down. Cool? Questions? The last thing that I will not cover on this video, because you should be able to do this, is what if I ask you to find the zeros? Which would be, how do I find that point and that point? You should be able to know how to do that. You learned that in Algebra 1, you learned that and reinforced it in Algebra 2. You've done it in this class before. You have the quadratic formula, you have factoring, you have all types of tools to do that. So as far as conics go, I will still expect you to know how to find the zeros for a parabola if necessary. Cool? That is all I have for you guys today. Homework is on the Learning Hub, on the calendar. Thank you for watching.